PMIS. PMIS. Hello computer, this is LLLL Colonq, and it's time to do a little bit of exploration in the magical world of cyberspace. Tonight we're going to be delving into the murky depths of Pokemon Emerald, and we're going to try and see if we can extract any hidden treasures and delightful sundries. So I guess with that short introduction, let's get to it. PMIS. Alrighty, so I guess for a little bit of context, my intention here is I would like to play through the classic Game Boy Advance title, Pokemon Emerald, but I don't want to play through myself because I'm fairly lazy. I think I would like to play through the game by teaching you, the computer, how to run through all of the various zones and battles and miscellaneous other requirements to beat the game. So yeah, that's the plan. It's going to be pretty involved to get there, but I think we have a clear path ahead of us, and we can get started. So yeah, what we're working with here is, over here we have the source code of Pokemon Emerald. This is of course not the actual source code, but it's decompiled by the folks over at the PRET project. I think that's github.com/PRET. They have all of these cool disassemblies and, in some instances, decompilations of Gen 1, 2, 3, and 4 of Pokemon mainline. So Emerald is fortunate enough to have a decompilation, which means that there is C source for most of the game with sensible variable names, and that makes things a whole lot easier for us because I am not a super competent reverse engineer, but I can certainly fuck around in GDB when we have symbol information available. So the plan is, up here we have MGBA, which is a pretty good, I think kind of the standard modern GBA emulator. And GBA has this nifty scripting feature. So I think if we go over here to scripting, we can bounce this down here, maybe divide this over here, do some shenanigans. Let's put MGBA back here. Let's put whatever our source code is, main.c here. Let's make sure this is, yeah. So in this little scripting zone, we can run Lua code, and that Lua has access to a little MGBA API. Let's actually bring that up. So this API allows us to do things like read directly from memory. So let's find an example. Where's our memory? So for a given emulation core, we can do things like take an address and read a single byte or half word or word or whatever from memory at an arbitrary address. And this lets us do interesting things. I think we can also write memory. So what we're going to do is we are going to write some Lua code. Well, actually, we're going to write some Fennel code, which is a small Lisp that compiles to Lua. And we're going to read the state of the game every frame. And we're going to use that to update an external program over a socket. And then we're going to read commands from that other program over the socket. And we're going to use that to influence the game, either by directly writing to memory or by, I don't know, firing off key presses. So some of that, I built some of that basic infrastructure that we're going to need. So specifically, we can do things like, I don't know, let's get this running. If I build this Lua script, and we load that script. Let's go up here, here. There we go. So we're now running our script. Tell GDB to run this again. Oh, that audio is super crunchy. Let's that not occur. Okay, we're officially decrunchified. This is currently spitting out game states super fast in this little window. That's just telling us whatever the current state of the game is. Let's actually make that not print because that is way too fast. Where are we doing that? We have a lot of data on game maps here. I think our handler for individual frames. Yeah, here. So here we're printing the current state to that overlay buffer. Let's make that not happen. Cool. So we'll reset. Load that script again. No longer printing that out, but what this script also does is it opens a network socket. It binds that socket on local port 31339. So we should be able to do things like if we connect to that socket, 31339, we can send commands. So the command format is just basically we're sending just words separated by spaces, separated by lines over TCP. So let's actually get to a point where we can observe the game. Do that again. Let's see localhost 31339. And so here we're on the gender select screen of the game. We can do things like press down, press up, and this is just sending key presses to the emulator. So we can control the game remotely over a network socket. So let's choose to be boy. Let's go for the old penis. And we'll press A again. And for the sake of brevity, we're going to be called A also. We're just manually entering the key presses we need so far. Trying to get to a point where we can read some state from the game that's meaningful. Get through all of Birch's dialogue. Playing in text adventure mode a little bit. And that's a long way to ship a kid in a moving truck. All right, so let's move right. We have some helper commands to move right by certain distances that we've just implemented. So if we see, where's our move command? Yeah, so that's just holding the given key for a certain number of frames, such that we know we'll move the number of tiles. Move right again. Get through some more dialogue. Get to an interesting spot. I always thought it was funny. I think they changed these in Ruby and Sapphire. I think the moving Pokemon are Machoke's, and they changed it to Vigoroth in Emerald. I don't know why. Anyway, so now we're on a map where we can actually like move around a little bit. So you can say things like this. But like, how do we learn things about the game, right? Because we can certainly make a program that just like presses like the correct directional keys and A and B to get through the whole game, but wouldn't be very reliable because there's like random elements to the game, right? There's not like a fixed sequence of key presses you can use to always get through the game. So if we really want to automate our gameplay, if we want to be maximally lazy here, it's going to be a bit tricky for us. So naturally, we need some way to get feedback. And the way we're going to do that is by reading stuff from the memory of the game and sending it over the same socket. We have a command for that. It's called send state. Right now, we're just manually calling this from the scripting console. If we go over here, we say sm send state. That sends a big blob of JSON over the socket. It tells us a bunch of different stuff about the current state of the game. And this is incomplete. We're going to have to develop this a little bit. But right now what we have is, it will tell us, if we are in battle, it will tell us where our cursor is and what moves are currently available for picking a move. And it will tell us what map we're on, the name of the map, right? So right now we're at Little Root Town, Brendan's house, 1 floor. And it will give us an array of cells, which is are the tiles visible on the screen. So for each this is basically a multi-dimensional array, right? So it's going to be kind of the top row that you can see on the screen, and the next row, and the next row, and the next row, all kind of appended in order. And for each tile, it tells us, well, a number of things that are pulled directly from the memory of the game, but most notably is this collision thing here, which tells us whether or not we can collide with the tile. So if collision is 0, we're all good, we can walk through the thing. And that's going to aid us in the future if we decide to develop pathfinding algorithms, or if we decide to just do some interesting stuff. So after this long cells array, we also have information about the size of the map. So there's width, there's going to be height later on, and also information about warps. So warps are things like, see the door here, and the stairs above my character. And these are basically transition points between the current map and a new map. So we know for purposes of pathfinding, if we step on a warp, we're going to be in a new map. So maybe those are things we want to seek out, but we don't know yet. So we just have X and Y coordinates of both of those, and also an elevation value. Because if you'll recall, if you played Pokemon Emerald, there are instances of like cool bridges and stuff that go over each other. Like I know a big example is the cycling road between Slateport and Mauville City. Cool. So other than that, we have the height, and we also have information about the player. So we have their secret ID and their trainer ID, which are, if you don't know, in Pokemon Gen 3, you have your trainer ID, which is the thing that is actually on your trainer card. You also have a secret ID, which is kind of like an extension of that ID. And the secret ID determines a lot of things related to whether or not a Pokemon you find will be, whether it's shiny or not. So if we end up wanting to do any RNG manipulation, which is pretty easy in this framework, we could like watch frames increment and try and catch shinies by matching RNG values to our secret ID. That may be fun later on. We also have our coordinates, like what elevation we're on currently. I think 3 is just the default elevation. Our X and Y coordinates within the map, and that's all for now. So we have a way of sending commands to the game, and we have a way of receiving feedback from the game. Right now, this is very limited, right? You can imagine there are a lot of other things that we want to know about. So for example, if we, let's say, move left 3, we press A, right? So right now there's a menu on the screen, right? If we press move right, it's not going to do anything because we're currently locked into this menu. And right now the state, if we send a state, is not going to tell us that this menu is on the screen, which is going to be difficult for us to automate. So we need ways to navigate menus. We need ways to tell like what dialogue options are on the screen, things of this nature. VOD, yes. Thanks for coming by. Cool. So let's press A again. Yeah, so I guess we can go into a little more about what we're going to do next, which I think is maybe we try and detect exactly this VOD. I think the way we're going to do that maybe is, so look at how we're reading the rest of our state. Let's see, get current state, right? So all we're doing here is we are just reading raw addresses from memory. So for example, we know that the player's X coordinate is at this memory address. Well, how do we know it's at this memory address? I think if my, we found that address by popping open GDB, and I think the player's address is in, if we go to G, I don't know where it is actually. G object events, G object event 0. Maybe not that one. Yeah, so G object events, I think I'm still exploring the source code myself, but I think this is a global variable that like stores all of the kind of actors that are in the current map. And conveniently for us, the 0 index in this array is always the player that I've seen. So if we get this actors, I think there's a just kind of, this is why it's very convenient to have this decompilation, because we can just do things like autocomplete symbol names and struct accessors and stuff like that. You can say, get the X coordinate. What is it? It's 12. And we say, okay, give me the address of this thing. That address is going to be exactly this address. So we've gotten some of these already, but there are more that we need. So since this, well, we have GDB FOS, so the window is not rendering. Since this window that contains the text VOD is rendering every frame, there must be something somewhere that is saying, okay, render this rather than not render it. So we need to find where that is. And yeah, I think that's what we're going to dig into tonight. So let's see. Let's kill the game again. Let's hide our scripting buffer. Let's do some source code diving. I guess let's make this window a little bigger. It's trippy. It's very trippy. My face gets all stretched out when my enclosure becomes too small. Cool. So where, if I were a menu, if I were a VOD, where would I be hiding? I think we can start by maybe literally looking for that text. So let's grep for it. Well, it's not there. Oh. Okay, so there's a scripts.inc file in the maps folder. This is in Little Root, Brendan's house, 1 floor. There we go. Okay, yeah. So there's this. This looks a whole lot like assembly language source that's just using a bunch of macros to like literally include strings. Also, point of fact, the string formatting in this is really weird. It doesn't use ASCII or Unicode. It uses this weird custom encoding. I think there's some step in, like, there are a lot of like literal strings in the source code. And I think there's some step in the build process that like does a weird transformation, because a lot of those literal strings are wrapped in like this funky preprocessor macro thing that does nothing, but I think it's just used for like sed purposes, but like we shall see. But this gives us a lead, at least. We know this this symbol is probably referenced somewhere. So let's go grab that. Let's look for that text. Cool. Yeah, so we know there's a script playershouse.inc now that seems to display that text in a message box. Let's look for that. Scripts playershouse.inc Vigoroth 1. Cool. Well, we could also see what the other Vigoroth says. Is that? The other one is going to say Uggo, Uggo, Uggo. So mystery solved there. Cool. So I guess Uggo, Uggo. Indeed, indeed. Welcome, Opal Resplendent. So yeah, so I guess we're gonna keep chasing this symbol. We can look for this name now. Let's see what we can find. So these are referenced by map.json, which I think is definitely not used in the original game source, but I think this decompilation has also has a cool custom representation for the map files that then builds into something that the game can actually handle. Let's see. Maps. Going to Brendan's house, 1 floor. Map.json. Let's just find auth 1. Yeah. So this is just telling us that maybe this is listing out all of the entities in this place. Object events, right? That looks a whole lot like the G-object events that we were just looking at, for sure. So I bet there is an entry in G-object events for both of these Vigoroths, as well as the background noise, as well as the player's mother, as well as anything else we can interact with. Like probably the TV or something like that. I guess we can just see right here. So here's the player's mother from the sprite reference. Here's the Vigoroth with the box, who's going to yell "Uggo, Uggo" at us. Here's the Vigoroth facing away. I guess he can't turn. And I don't know why we have woman 4. Oh, I wonder if... Is this... Where are we? Is this for all of Little... This is just for Little Root Town, Brendan's house, 1 floor. I wonder why we have... This looks like script associated with the rival's mother. But I guess that's all just in this area. As well as Norman, dad. Oh, maybe there's like events, maybe there's something that happens later in the game. I don't remember like the actual, like all the cutscenes that occur in the mainline story, but like I know there's like post-game shit, like when like the roaming legendaries spawn. So maybe there's additional stuff that happens in this area that is interesting. But either way, we can expect... I wonder if... How many of these things are there here? We have Mom, the Vigoroth, we have 2 Vigoroths, we have this thing, we have this thing, this thing. These are different. We're getting all confused here. Let's count the old-fashioned way. 1, 2, 3, we have 4, we have 5, we have 6, we have 7. So we would expect there to be 8 relevant entries in G-object events. So I guess let's see how we can disambiguate them. We're unlikely to get a string that's useful out of GDB here, again, because the text encoding is all fucked up. So like, we're not going to get any nice String. We have a old Botterino. Cool. But we should be able to disambiguate based on one of these IDs. So probably the graphics ID in particular. Those are going to be unique for each object. So I think we can probably figure out something there. So let's see if we can find that. So 0 is the player. I wonder if we have, yeah, we just have a graphics ID field. That's 0. That's not very promising. Well, that's better maybe. Let's just print out a bunch of these. Okay, so we have at least 3 objects with graphics IDs in addition to the player. So that makes me think that these are sequential. So this is probably one of our Vigoroths, and this is probably our other Vigoroth, and this is probably our mother. Let's see where we can. I bet this is the name of like a pound to find somewhere. Let's see if we can grab that. Yeah, looks like it. It's going to be in one of our. Okay, yeah. Event objects.h. This is 215. So our hunch was correct. So object events 1 is our mother. Let's just bring up event objects.h. Yeah, if we go to 95, yep, we have Vigoroth carrying box and Vigoroth facing away. That looks pretty nifty. Cool. So from there, I think let's look a little more deeply into Vigoroth facing away, which is G object events 3, because that's the guy who has our current guy or girl who has our current dialogue option on the screen. Let's see. So what do we got there? There's probably some. It's active. That's useful. So the thing we're looking for is, if we bring up that map.json again, go to we are looking for this script thing. Like what? So we're trying to find where this script is called. Which is maybe not here. Maybe that information is elsewhere. So let's try another lead, I guess. So if we go back to that playershouse.inc file, we have this message box thing, which is either an instruction in a probably like just like a DSL thing. If we grep for that, we're probably going to get a million results, but we'll do it anyway because we're brave. Yeah. Oh, cool. It is just a macro, whatever this assembler is. So our goal is to find, like, it looks like we have a lot of leads potentially. So I think what we want off the bat is we just want to be able to read one bit that's going to tell us, okay, is there a message box on the screen? It might not be that simple precisely. We might have to go through a few layers of indirection to actually get there, but I think that's the goal. We're gonna have just a billion lines of all the dialogue in the game. Yeah, for every zone. Let's see if we have anything interesting that's not in. I guess we can just go into. Yeah. So that looks like this is all in. Why is all of this in PokeNav match call GFX? Let's see. Maybe we need to look elsewhere. Let's look for those things right at the end again. Oh. These macros seem promising. Okay. Macros. Event.inc. That seems like what we want. Message box. Yeah, so I guess message box, that.inc, our intuition is correct. It is just like assembly that is included somewhere. And these things are just like a domain specific language built out of a bunch of assembler macros, which is cool. Cool. So this is calling whatever the type of message box is. I don't know if call standard is an actual ARM instruction or another macro. Probably another macro. Certainly is. It calls the script in G standard scripts index function. That seems promising. Let me say. Okay, well, I don't actually know how to get a source location in GDB. We're gonna find that out. Cool. Let's see. Well, this is certainly a lot of things that are useful, but not quite the thing that we want to know. Say info variables. Is that what we want? Info variables G standard scripts. That's not useful at all. We're gonna resort to good old grep because that's easy enough. It's probably an include G standard scripts. Nope. Source. Yep, that's where it is. It's extern, so maybe it's just defined in one of those assembly files. That seems likely. Or not. Cool. Oh, there we go. So we have some assembly symbols and data. Data. Event scripts.s. E standard scripts. Okay. So cool. So now we know. Let's get a little more space somehow. So we don't need to see the emulator. if we go back to map.json, or if we go back to, what are we looking for? Definition of message box. Yeah. So we're expecting well, regardless of what this actually does, we're expecting this to call one of these functions based on the index that's given. And we expect message box. There's a bunch of these message box types which correspond to indices in G-standard scripts. And yeah, the message box macro just calls call standard with one of these things. So I guess these are our different types of message box, which is useful. It would be especially useful if this is stored somewhere, right? So if we can query, okay, is the thing a yes, no? Is the thing an auto close? Is the thing just a default message box? I'm starting to suspect it isn't, because this is just like an index into like a jump table, basically. But either way, the default for this message box macro is just message box default, aptly named. And if we go back to our little root thing, what was that called? Not map.json, we had scripts.inc. That was used. Where is it? Not there. Layer house. Yeah, there. With just message box default. So we know that this message box is being the display of this thing is being prompted by a call to presumably this thing. So let's find that thing. Oh, the keyboard is currently, I'm using a really, really junky keyboard. It's a Bluetooth Logitech 2-in-1 trackpad chiclet keyboard. It's definitely subpar. My desk is super crowded because I have like a real keyboard on it and then also this keyboard, which I'm using to control my streaming laptop. So it's the best we can do for now. Definitely not ideal. My usual keyboard, which is much louder, if I type on that, probably gets picked up a lot more, is a Unicomp replica Model M thing with buckling spring switches, which is much more tactile. So I'm not super used to this one yet. Hopefully won't have an opportunity to become super used to it. Also, welcome to the Quick. Cool. So we found our message box macro. Let's try and figure out, looking for G-standard scripts. We're looking specifically for std underscore, where was that file that we were just in? Blah, blah, blah. Yeah, this guy. Let's grab that guy. Keep wanting to get grep, but I don't think that's what we want. Cool, so that's just in the conveniently named stg message box.inc. Going on a long goose chase through these assembly routines. Okay. So this says message null wait message, wait button press, return. That's kind of exciting. Oh. I guess it makes sense. I guess we can compare with message box yes, no. Yeah, this does this thing to like this little DSL is kind of cool. It's fun. It reminds me of I like clever things like this. It reminds me of in the NetHack source code, the classic roguelike. There's some cool stuff you done to like for the definition of the monster types. It's not quite like this, but like there's of course not like an assembly DSL, but a cool preprocessor DSL. Okay, so let's find all of these macros. They're probably just going to be in this data scripts folder. Let's see, message. Let's search message colon. Oh, that's no fun. Let's search message colon. That's especially not fun. Okay. Maybe in here? Here's our macros. It's gonna be somewhere in here. The event dot macro mess. Yeah. Okay. Okay. Starts displaying a standard message box containing the specified text. If text is a pointer, then the string at that offset will be loaded and used. If text is null, then the value of script data 0 will be treated as a pointer to the text. The load word 0 in message box sets this value, for instance. Okay. That makes sense. So we look back at, let's split this just to keep track of things. We look back at our .macro box. This didn't make sense before. This load word macro, I suspect, I just glossed over this because I'm like, oh, that's some ARM assembly thing. This is, you can tell how well I know ARM assembly because I just assume everything is an instruction. This is probably a macro that from this comment makes me think that there's like some small number of like scripting DSL specific quote unquote registers that other things can refer to. So for like this message null is referring to the value in quote unquote register 0. And load word is loading whatever this macro substitution is into register 0 maybe. So let's find load word. Yeah, sets the value at the specified script data index to a fixed 4-byte value. That makes sense. A little. So these things, okay, yeah, now I'm understanding a lot more what's going on. These things aren't actually a DSL in the sense that these macros are actually expanding to ARM assembly that does something. They're a DSL. This is ARM assembly that was probably handwritten as part of the decompilation project. In order to, I mean, it would be either way, but in order to generate like another DSL that's just a binary DSL. So I bet there's like a binary format for describing script commands within the game. And this is just producing that binary, right? So we have some opcode basically within our little scripting state machine, 0x0f. And that's saying, okay, store, take the next 1 byte, that's an index, take the next 4 bytes, that's the value, store, and then the interpretation of this 6-byte like instruction is store value at register test index. Okay. Cool. Well, we can dig into that later, but at least we know how it works a little bit better now. So we know that the semantics of this thing, of message, are take the thing that we load worded, which in this case should be I think the address of text, right? We're calling this thing on, where is it? Let's get our player house. Yeah, we're calling message box on, this is the text variable, this thing here. So this is the address of the actual text. This is the type of message box, which is redundant because we have this default thing. We're loading this pointer into our like weird script interpretation state machine register number 0, and then when we call standard type, which is message box default, that gets looked up in G standard scripts, which gives us a pointer to this thing over here, which gives us, which calls message null. Message null expands to whatever this state machine instruction is, and this is going to be expanded to just null, but the semantics of this probably mean load from, if this is null, load from register 0. Okay, so now that makes sense. We know how the a reference to the appropriate string to get displayed is being conveyed. Now what's this wait message thing? Because I guess wait message, I suspect this probably waits is like as the text is displaying on the screen, which allows you to do things like if you hold down the B button when the text is displaying, the thing speeds up. And then this is actually waiting for like the confirmation button press to close the text box, which can only occur when all the text is done displaying. Let's see. So let's find both of these. They're probably just in here. Macro wait message. Yeah, and these are just going to expand directly to opcodes in our little state machine. Wait button press. Okay, so that's cool. Maybe. So I guess now we have to bite the bullet and find out what the interpretations of these things are. Like where the hell is the thing that is reading the byte hex 6D and branching off of it and doing something? So let's find out. I bet that is source code. We have something called event data. There's a bunch of stuff happening here. Doesn't look wrong. Oh, this looks like reference to actual like mystery gifts. It's in here. Maybe we just grep for 0x60. Grep and include too. Well, that's a lot. Let's just delete this. We keep grepping this dwarf dump.txt that I produced earlier when I was mucking around. Okay, bunch of stuff here. Well, we have this, that looks promising, this script command table, which is telling us directly that scr command wait button press is at index 6D. So that looks a whole lot like a jump table that is dispatching on our little opcodes and telling us what to do with them. Let's look at that. Data script command table.inc. Okay. I guess let's just look. Are the definitions of these things in here? doesn't look like it. So let's look for this. Having a fun little evening of grepping. Okay. Well, that is promising because that is just a C function. Let's see. scr command.c, which is where we were before, where this extern is defined. That's cool. Come full circle. Probably could have realized that sooner. Okay. Here's our actual definitions of our terms in our little domain-specific language. So now we've gotten there, and so we can now look up and probably just assume that these names of these macros. Well, let's find where that was again. Where was that? Yeah. So our different message box things are just going to call these macros that ultimately end up corresponding to these function calls. Let's see. Cool. Cool. Okay. Message is probably what we want to look for. Yeah. So message, we have this. We're calling script read word on our script context. If the thing we get back from it. Okay, yeah, that makes sense. So what we're doing is, let's look for the definition of message again. Where was that? Macros. Event.inc. Macro message. We can close this, get a little more space. Oh boy. Dot macro message. Yeah. So message, all that is the single byte here, which is being dispatched somehow already by looking up one of these functions in that table. And then 4-byte word that is a pointer to the text. So all this is doing is saying, okay, hey, script read word presumably is reading a 4-byte word, or maybe this is reading a word and then dereferencing it. I think pointers are 4 bytes here because we're on 32-bit ARM. Question mark? Maybe. Guess we can just check. Yeah, that looks like 4 bytes to me. Cool. I guess we can also just look up script read word. Right here. Nope. Let's see. Script read word. Where are you? That looks like where you are. Nope, that's just reading the word itself. Oh yeah, because we're Oh yeah, this is fine. We're just casting into a pointer. I'm dumb. Cool. So we try and read a word. We try and read this pointer here. If the pointer is null, then we just use whatever is in context data 0. So that's exactly that register thing that we were noodling about earlier. Try and find the definition of script context. That's probably an include. Is there an SCR? Can we search struct script context? Cool. Yeah, we have 4 4-byte registers. That's pretty convenient. Oh, we even have a little stack. This is very cute. I wonder, well, I've seen enough speedruns of these games that I know there's all kinds of nonsense you can do with arbitrary code execution and stuff. But it's sort of nice that there's like a little stack machine right there in the dialog engine that you can kind of presumably just do whatever you want with if you can write some memory to. It's like here we're like, yeah, well, either way, it's for another time. Yeah, so we get a pointer to the text and we call show field message on it. Where is show field message? Show field message. Where are you? Field message box.c, very aptly named. Neat. So what are you doing for us? So if we have some global S field message box mode. I think that's global. You can see what it is. S field message box mode. I think that just means they use S as like if it's static. Yeah. Cool. So if we're hiding message boxes, hide it. Otherwise, expand string. Oh, okay. I see. No, that's not what I thought. So this is saying this is set later on. So this is saying if a message box is displayed, don't do anything. Otherwise, display this message box. Very cool. So can we just, what is this? Where is this field message box normal defined? Is this 0? Are we reading the right? Go to include, probably there. Find that, find that. Well, I guess we won't know, it's enum. Well, either way, let's bring back our, not that, not you. Bring back our emulator. I'm not gonna be able to press any keys. We need our little console. Where's the netcat? Where are you? There you are. So now we've closed the message box. That's very obnoxious. Let's resummon face, resummon GB. Is this still going to be 0 then? Yes. Okay, we need to make this go elsewhere. How do we do? Let's just move over here. All right, now we're cooking with gas. And widen a little bit. Let's narrow a little bit. Yeah, cool. Now we shouldn't have things popping up in irritating places. Yeah, so this is still 0. Maybe this is just GDB being kind of wonky. Because I would expect let's go back to, where are we looking? Field message box.c. I would expect S field message box mode to change depending on whether or not a message box is displayed. But maybe we need to do a little more research. Let's see. So I guess the next thing to check is what happens when we press A. Let's look up here. Wait for A or B press, right? So we have this setup native script thing. What does that do? And this seems kind of obvious. I assume this join new detects, okay, is the A button now being like pressed this frame when it wasn't pressed last frame? Like, do we have a new like distinct like depression of the A or B button? And give us true if so. But that's being used as a callback in this setup native script. Where is that? Well, we can find it. Twitch needs a grep category. Okay, so that changes something up in our little state machine. This is getting a lot of indirection here. Where was the state machine? Some header. Script.h? Yes. So what's going on there? We have script mode native, and so I assume this script mode means, okay, if we're interpreting bytecode, we're interpreting those like opcodes, like such as message box and wait message, etc. If we're in native mode, we're just calling this function pointer, I guess. So that's cool. Where's the actual event loop here? This initializes the script. Run script command. Okay, here we go. If we're stopped, do nothing. If we're stopped, again, do nothing. I think this is probably weird like this because I don't see any reason to do this, but I think the aspiration of this project is that if you build these sources with a suitable compiler that is included in the project, it's like a fork of an old GCC version, you get byte for byte identical ROMs. We are not doing that. I'm building with a new ARM cross compiler on a current GCC version, but I think there's a lot of weird quirks just to make GCC spit out the exact right thing. Okay, doesn't matter though. Okay, if we're in native mode, we're going to call a native function. If we're in bytecode mode, we're going to do the thing we would expect, which is read 1 byte from the script, use that to look up a function in the command table, and call that function. Cool, that's easy. Oh, that's kind of funky. I don't know what that does. If we're in native mode, okay, so we call that function pointer. If it returns true, we go back to bytecode mode. And then we fall through. So this is interesting. So what that means is, okay, yeah, so now I understand. Well, I don't understand exactly how this interacts with the main game loop, right? Is this all this stuff run every frame? What's going on here? Thank you for the follow, Patterns in Droves. It is much appreciated. I don't have nifty follower alerts on screen yet, but I can still awkwardly point them out and make people feel like they've been called out publicly. But thank you. Cool. So I can kind of get the gist of what this thing is doing now. If we go back to, where was it? So it's just in script.c, no, scr commands. Yeah, so what this is doing is it's installing not wait for sound effect finish, but I bet the principle is similar. Wait for ARB press. So this is installing this native thing and switching our bytecode interpreter to native mode. Oh, thank you. Yeah, it's a journey for everyone. It's a journey for me as well, for sure. I don't have a ton of background in this, and it's exciting to play around with. I hope we can get something that's mutually beneficial and fun out of it at the end. I have lots of exciting ideas for things that could eventually be built on top of this, right? Like the ability to script the emulator in a pretty high level way is super nice, because we can do things like have a network connection, right? Like GBA Pokemon games you can't send things over the internet, but this would enable us to do cool stuff like I don't know, I have ideas of like challenge runs where like a team is pulled, like for example, like Twitch chat could submit teams to a website, and then every battle 6 Pokemon are pulled from the website, like from like a queue or something, things like that. So there's cool stuff we can potentially do, but it's all predicated on us getting a good understanding of how all this stuff works. So let's keep digging in. Neat. Yeah, so we have an idea of what this does, right? So this is over here. What this is saying is if we are in native mode, which this puts us in native mode, and our currently installed native function pointer returns true, which this will do only if there is a new A or B button press on that frame, presumably, then switch back to bytecode mode and return true in any case. Otherwise, we're just going to stay here, right? So this just like so installing this just kind of like blocks us from interpreting future script commands until we've received an A or B press, which is cool. Now I want to determine, like, this looks like it runs. So I think the way this works, without reading too far ahead, is my guess is that unless there's something that's explicitly stopping us from moving forward through our little bytecode script, we're going to go as far as we can every frame. So if we have a bunch of instructions, like, I'm gonna have to remember these names. Not there. Oh, it's in here. If we have a bunch of instructions like message null, wait message, wait button press, return, right? All of this is going to we're going to try and run all of this every frame. The thing that's going to stop it from all running every frame is explicitly this wait message, which is going to like halt our whole VM here and just return true immediately without running the rest of the script. But like the pointer, our instruction pointer is still being like everything is all saved within this script context. Like we have it's a little VM. It's cool. So we have a better idea of how that works. It does make it a little tricky to grab some water. I'm still a bit unsure of how we're going to determine, like, because the end goal of all this is being able to tell in the client, like in our little Lua script that connects to the emulator, like what memory do we have to read in order to get a decent like view of the current dialogue state of the game. So I guess if we're being really ambitious, like a perfect view of that dialogue state is this entire script context. That seems like, obviously there are certain things we can't send, right? Like we're not going to send the native pointer, but we could look like, I assume everything stored in this native pointer is just going to be a known address, right? Like go back to, we don't have enough screen real estate, I'm finding. If we go back to show field message, or where is that script? Not here, it's in scr command. Native, yeah. I assume everything past here is like, it's always going to have a fixed address, right? So we could build a table from those addresses to like strings or something to tell us like, okay, are we in this frame currently? Are we in a native script mode, right? So let's actually try that. Well, we still need to figure out where this context is stored, like globally, right? We know run script command takes a context, and we know that there's an init script context here. But I guess we don't know whether there are like, my guess would be that there is just like a global script context. But well, I mean, I guess that explains this. Well, we have an S global script context and an S immediate script context. I'm not too sure what the difference is, but we'll have to see. It's not very helpful. Well, GDB will even tell us what that is. Well, again, let's not get too far ahead. Let's go back to the game. Let's continue. Let's get back into a dialogue. Oogie. Excellent. Let's break again. Okay. So where are we going now? Let's go back to script.h so we can see a little more. Yeah. I'm gonna make GDB big over here. That's gonna be nicer. Oh, that's gonna be a pain in the neck. It's going to, well, I guess we can just put, let's see, I have a little helper function to like denote a specific Emacs window as where to put the GDB source code, because it likes to go all over everywhere, but it's still misbehaving a little bit. So we're gonna have to experiment. Okay. What are we looking for? We're looking for this G. We can split this even more. We don't need to be quite so tall. Squash. Oh no, I'm squashed. Oh dear. Okay. We're looking for, I already forgot which of these we denoted as. Well, it doesn't matter. We're looking for some script.c probably. It's a static. This guy. Yeah, so that looks exactly what we were looking for, because now the native pointer there is, you can see, wait for A or B press, which, or it's the address of that function, which is what we would expect, because we would expect to stay. If we go back over to here, where are we? We made a new, we're doing all kinds of shenanigans here. We'll call this big GDB. This emulator, whenever MGBA has a, if you're wondering why this looks so weird in the top middle, MGBA has this GDB server mode, but if when you have like when you've used a breakpoint, when you're not currently running, like you've broken the program and you're using GDB to examine things, the whole MGBA renderer shuts down and it just doesn't display anything. So it ends up just displaying whatever you had on the screen last. Like it doesn't refresh. So yes, we can just hide that because it looks really bad. We'll put that up. That seems useful. Or maybe script.c. Yeah. So, well, this is exactly what we would expect. This result of having native pointer equal wait for A or B press, because as we saw, the way this script interpreter works is until this thing returns true, we're still going to be in native pointer mode, and we're still going to be returning right when we get here. We're not ever moving on through this fall through and actually processing any of the bytecode, or which all the bytecode is going to do is we're going to move to the next instruction, which is probably going to install another native pointer. I think it's wait for, etc., etc. I bet also, because the, where is that thing that we're looking for? It was in standard message box thing. Because this does wait message and then wait button press, wait message installs a native script for is field message box hidden. Is field, well, I don't know where that is, but I bet if we kill GDB while, so let's, what are we going to do here? We'll open eShell. We'll press A. We're going to set our text speed. Press down. Press A. Is that not it? No. Press B. Press down. Press down. Press A. We'll go to our options. Let's set our text speed to slow, so we have a little time. I'm not super quick with the fingers. Can we just press start? No, we have to press B. Press start. Okay. Press A. So now we're in slow. We're slow mode. So the text is still being displayed on the screen. We didn't get the exclamation points on the Fugi. Can't see that now because of our excellent emulator display refresh not happening. But I bet that now if we print, oh, excellent, right? So this is now is field message box hidden, which is the native script installed by wait message. So if we go back to, let's see, where's our standard? So we do wait message first, which installs is field message box hidden, which presumably, like we were guessing, that this waits until the text is done displaying. So it looks like that happens. And then once the text is done displaying, like if we continue, let's put MGBA over here now. Oh, that's just a, we'll kill it again. I think it doesn't display because I'm using EXWM, which is the Emacs window manager, and it switches to windows based on their title. And MGBA likes to put the FPS in the title, which changes very quickly, and so there's like a race condition that happens there, but we'll fix that later. So now we've let it run. I don't know if we let it run long enough. Yeah, we did. So the text finished displaying, those last few exclamation points got in, and now we're waiting for an A or B press. So what does that mean? I think what it means is if we grab the, say, dot native pointer, we grab this, right? We can take this value and compare it to some known values, right? Such as this one precisely here. And we can see what's like what we're currently, I suspect this will mostly be used for waiting for things, or like playing animation. But at least it'll give us some idea of like what the game is currently expecting of us. So that's kind of useful. So let's grab the address. Cool. And let's see if we can do some stuff with that. All right. Let's bring up MGBA again. Let's continue. All right. Okay. What to do next? So we should be able to, if we open up our scripting window, yeah, we should be able to run some commands, right? I think we have to console, I think we just press, like, can't just evaluate an expression, we have to do like console log. This wants a string specifically. Yeah, so I think if we mu, or toString mu, is it called that? If we open up our scripting API, is it read32? Looks like read32. Read32, that address. Bing, bang, boom. Okay, that certainly looks like a number. Is it the right number? We'll see. That certainly looks like the right number. That is, so this address matches the address of wait for A or B press. So cool. So from Lua, we can now determine kind of like what the current like non-instantaneous state of the scripting state machine is, right? These other stuff, like that's just like the bytecode instructions are just, I don't know about all of them, but the ones we've seen at least are, they're just all running within the same frame. But these native things are used to kind of branch off of other stuff that's happening in the game. Like waiting for the player to press A or B, or waiting for the text display animation to finish happening. So let's go over here. Let's make a mapping of, let's call this native script handlers. And we'll do stuff like this. I'd prefer to have the hex. That is the address of wait for a, let's use consistent names. No, we can just use our own names. We'll go to, I think this is called kebab case, because it's like veggies on a skewer instead of the camel case or whatever it's not camel case, but it doesn't matter. Yeah, so that's one that we know. The other one that we've seen is field message box hidden. Is field message box hidden? Cool. And then let's make a little thing called get script info. Okay. We're going to say get the native pointer, which is going to be just mu read32, this address over here. And then our script info, we'll make a little map of it, just like we have battle info, we have player info, we have map info, etc., etc. We just have a bunch of these maps within this, like the JSON thing that gets sent from this client to this server to the client. we'll say, what do we call it? Status. Let's not just say state, we'll say status. That sounds fancy and cool. What is our map called? We called it native script handlers. Native script handlers native pointer. That looks like a thing. We can't evaluate it because this is fennel. Okay, what are we doing then? We can say down here, say what is our script state? Get script info. Cool. And then just for the sake of it, I guess, we'll print out just that. Dot script. Shouldn't be too long. Neato. Next, I guess we will reset and load. Cool. So now we're in wait for A or B press state. Let's if we just play the game. Let's go back to netcat. Press A. This thing in the top right-hand corner should live update. Oh, we have to reconnect because we restarted the server. Okay, cool. It's gonna like, we're not currently in a state thing, right? The state machine is currently inactive, I would think. Or at least the native pointer returned true, and it doesn't actually, we never actually like set the native pointer back to null. We just move out of native mode. So we'll have to send that over as well. But let's see. If we press A again, we go to is field message box hidden until the thing is done, and then we write out wait for A or B press. That's very cool. And those are going to be our only two options right now. And I think the thing, like, we're going to print out, we're going to get nil or whatever if we're in any other state. But this is a start. Because when we start automating this thing, we start receiving these states and then automatically responding to them rather than just manually typing press A, press A, press A. We'll be able to tell, like, hey, the game is waiting for an A or B press. So naturally, we need to send an A or B press. Or the game is waiting for text to display, so either we press and hold B or something, or do nothing. Probably nothing. Anyway, let's move our text speed back. Cool. And now we think about what to do next. Well, maybe one thing to do next is try to identify exactly, we could already do things like we could get the dialogue, like we could read the Fugi. It will be irritating, but I think I already have, let's see. Oh no, I just did it for moves. A lot of these arrays I just kind of pulled out of the game previously. Like, so for example, rather than actually trying to decode the encoding of text, I just made a mapping of move indices to their actual UTF-8 names. So that's a little nicer to handle. And similarly for like things like, I just made a mapping of town and route indices to strings that so we can handle those a little more nicely versus trying to. But I doubt we want to do that for every line of text in the game, and of course it's also in a much less structured format because it's all in these assembly macro DSL thing. So we could write a decoder, or we could just know, like, I think it's unlikely that we'll have to rely a lot on on actually parsing. Well, I hope we don't have to rely a lot on parsing NPC dialogue. We should mostly rely on, like, okay, is there a yes or no prompt on the screen? Are we being prompted to select a Pokemon in our to switch into? Are we being prompted to select an item? And like, what is the state of the battle if so? So I think we probably have enough to get by. So let's maybe move on by digging into and evaluating like other native pointer handlers. So I guess, like, let's see. Let's pause again. Let's do some grepping. We're back on that grep grind. So we're going back to script or scr command.c. Probably go to script.c over here. That'll be useful. I'll keep my beautiful expressive face corner. And we will say, where are the instances of setup native scripts? And what is called there? So it's actually all in. Wow, that's nicely short. So it's all in scr command.c. But we have this one is, ooh. Where is that? Oh, that's kind of cool. That's really odd. So if we were wondering whether we could use this thing to do some kind of nasty arbitrary code execution thing, there is just a VM instruction that just reads the next word and like casts it to a function pointer and calls it. So you can just jump wherever. If you can include a that's actually probably really nice for ROM hacking, right? Like you can just like install whatever address you want, like along with this instruction in your dialog script somewhere, and just like which is probably really easy with just like a hex editor, and then just like go wherever. That's kind of cool. I like that, but we can probably ignore it for now. I wonder how often that's used, if it's used a lot. Doesn't look like ever. Well, that's promising. Well, that's fine. So let's look at the other instances of this. Setup native script. Is palette not active? I think we can just say, is palette. Oh, well, do we have to do some horrible GDB thing? Info address. Oh, I spelled palette wrong. Okay. Well, we're just gonna grab a bunch of these, and then all the functions that are passed to set up native script, we can just plug them right into here. Is palette, is that not active? That's a mouthful. Is palette not active again? Is palette not active again? Oh, this looks like it's used for things, oh, like for fading to white. Just like screen transitions, I guess. Kind of cool. Run pause timer. It's called delay. So maybe this just freezes, like waits for a certain amount of time. Either way, we can grab our address, plug it into our source. I mean, ideally, right? So one thing to note, I guess, is that these addresses are not like canonical in the sense that the ROM I'm using, since it's built with a modern compiler rather than like the old compiler to be identical to like the actual ROM. Like these addresses are not going to match those that occur in like an official Emerald ROM, like that you can rip off of a cartridge or download somewhere, right? So having these addresses just kind of raw in the source is a little irritating, in the sense that like if we end up rebuilding the thing, like, and in a non-reproducible way, like we're going to have different addresses and we're gonna have to redo a bunch of work. I did it this way because I couldn't get debug symbols working using the old compiler, which like this whole thing is like predicated on us being able to like do stuff like this instead of not stuff like this in GDB. Because I really don't want to stare at like, I don't even know what I would do, like stare at Binary Ninja or something or Ghidra and try and figure out what the fuck is happening. So we're gonna stick with the version that has symbols. But in any case, what I'll probably do eventually is produce just like a big CSV file with a mapping between like with like names, short names that are valid identifiers, GDB command to produce an address, and then or something like that, and then just like run that to automatically generate a mapping, and then like have just the short names in here to look up, like something easy like that. But for now, we're just gonna hard code the addresses. I think that's fine, because we're not planning to change the ROM anytime soon, and this will be nice enough. So we have run pause timer. Where are we going next? Wait for sound effect finish. There. Info, address, wait for sound effect finish. There we are. Wait for sound effects finish. Wait for fanfare finish. Doot. Doot. Wait for fanfare finish. And there really aren't that many of these, so I'm kind of happy to do it by hand. Info, address, is BGM stopped or paused? Wait for movement finish. That's definitely a cutscene thing. Got moving NPC map group. I think this map group and map num pair denotes like what area of the game you're in. We already have a mapping here that's exactly that. So this is the map group index, and this is the map num within a map group. I don't know why it is that way instead of just being like just a map num. That's just like wider. I assume it's because maybe these map groups, like there's like sprite palette stuff that's shared between them, maybe. Well, I guess maybe these are like, they form like a cohesive region, but I guess like this one is like every route. So like, I don't know, they're mostly just like interiors. The other groups are mostly interiors of specific buildings, or like all the interiors in a town or something. So I don't know. There's weirdness there, but well, we will figure it out eventually, I'm sure. Okay. What were we looking for? This address is one we just had. We're looking for wait for movement finish. Info, address, wait for movement finish. There we go. Wait for movement finish. Cool. Wait for movement finish. Is freeze player finished? That sounds exciting. You have some lock all. Lock all freezes all object events except the player immediately. The player is frozen after waiting for their current movement to finish. Maybe that's like initializing cutscenes. I'm sure we can find it. I mean, we just have to grep through the those assembly files that have all these macros that generate these things, and we can see exactly what thing is locking all. And it's pretty easy to read through those, so shouldn't be too bad. Anyway, so here is freeze player finished. These seem like we kind of expected. These are almost all like waiting for something, which is nice because like what we do next in our bot is going to be determined a lot by what the game is waiting for. So kind of perfect. Is freeze selected object and player finished? That is verbose, but verbose is nice. Verbose is much nicer than looking at this. I would much rather look at, what are we locked up? Oh, we switched to our other monitor. Is freeze selected object and player finish? Is freeze selected object and player finished? Ooh, mouthful. Is freeze player finished again? Is field message box hidden? We're going to reorder these just so we have some kind of order. Wait for A or B press, and we'll pop that down. These are in the same order that they are in the source file, so we have some kind of consistency. And then that again, the go-to, or this is hide mon pick. I don't know why this is not. The hide function returns a pointer to a function that returns true once the pick is hidden. That's exciting. How did we miss that? Ugh. Wait for field of. We'll skip that one for now. Info address. Wait for field effect finish. I don't know what constitutes a field effect. I'm excited to learn though. Is cry finished? It's probably Pokemon cries at the start of battle. Go address is cry finished. Grab its address. This is therapeutic. I have some chiclet keyboard mumbling about addresses ASMR. There we go. Is door animation stopped? That's a good thing to know. You certainly don't want to lose track of whether your door animation is stopped. Don't want to get stuck in those doors. Is door animation stopped? And it's another of our is freeze object. Well, no, this is different. Different one. We had is freeze selected object in player finished before. And it is at a different address. So we'll just grab the same name. There's go to native. And we're back up in the bottom to is palette not active. So now we need to figure out this hide mon pick stuff. I wonder what that's all about. I wonder if that is waiting at the start of battle for or no, that's for the player sprite to move away. I wonder maybe that's encompassed by this, but maybe things fainting or something like that. I don't know. We'll see. Either way, we have to find hide mon pick. There's show mon pick. We want hide mon pick. What is up with that? What's going on there? We want script menu, hide Pokemon pick. Where are you? Where do you live? You live in, as expected, script underscore menu.c. Hide Pokemon pick. Okay. So it always returns is pick box closed. Okay, this is weird. So this seems to me like there's some kind of task scheduling system. And we use this, we have this callback thing happening. Because we need to find a task that's displaying the Pokemon pick. And if we don't find it, then we return null, and then over here we don't ever install the script. We do find that window, we bump its state and return is pickbox closed. Maybe this makes the thing active somehow. Maybe this indicates that the thing needs to be. Well, we're hiding it. Oh, well, this is probably waiting for something, and we're checking here. We're checking to make if it's equal to task none. So maybe this activates the thing, and then there's some other handler that takes care of player inputs in that, and then this is actually waiting for the pick to go away. I don't know, man. This is some funny business. I don't even know where this occurs. Maybe it's like it could be like the pictures that pop up in like the Hall of Fame at the end or something. We'll see if we end up encountering this a lot. But either way, knowing the address of is pickbox closed is always going to be the thing that's relevant, because that's just used to return either that or null. Info address is pickbox, one word. Yep, closed. Cool. So now we have a decent idea of all of the native script handlers. So presumably all of the things that the scripting VM can be waiting for us to do as a player. Maybe the next thing is print g. What's our? It's in script.c s s global script context. Dot mode. Where are those modes defined? Gotta get a hold of those modes. If you're doing anything, you gotta be aware of the mode. What mode? What configuration? What status? These are all valuable things to know. Right now I'm in talking mode, I'm in nervous mode, I'm in speaking mode, variety of other modes as well, so it's good to know, good to be aware of. Okay, it's just a U8. How useful? Well, where is the define that tells us what the thing is? Script mode stopped. Nope. Script mode stopped. Where the hell is the thing defined? Oh, it's an enum in here. Yeah. Yeah. Okay. Probably these are 0, 1, and 2. That would make sense. Let's say local script modes 0 is stopped. 1 is bytecode, which we should never see, I hope. And 2 is native. And we can get the script mode by reading this address. It is a single byte. Script info. Let's also get the mode. Mode is emu read 8, this address. Cool. Now we can just say mode. So now our little output should have that as well. Let's build. Let's get our emulator fired back up again. Scripting, continue. We're gonna have to reset. Why are we only seeing mode now? It's because our native pointer, that means status is nil, which means that this lookup is not. Well, let's just print native pointer as well, so we know if it's something that some horseshit. Let's reset. Let's load a recent script. Okay, that looks like an address. Can we not copy and paste because it's printing out over itself so fast? Let's 136017545. It's this address. 7689 is the end of it. 7689. Did I miscopy? Is cry finished? No. That's very strange. What is happening there? Maybe there's just garbage there? We're not in the native mode anyway, so maybe that's just being used for some other thing. That makes sense, maybe. I buy it. I will chew. Let's fire up netcat. Let's press A. Yeah, okay, that makes sense. Well, probably that native pointer is reused for some other stuff. It's just that when we are in native mode, it's treated as a function pointer. Makes sense, makes sense. Let's stop printing native pointer. We also really want to, can we clear the overlay buffer? Scripting API, clear, please. Yes, here's a clear. What we're seeing currently is that this text is very hard to read because it's printing over itself, which is not ideal because it leads to weird situations like this where it's like, what is the current state? So let's reset, reload. I wish there was a way to just like, I don't think this scripting API is actually, so MGBA can run in two modes. There's this mode, which is like using Qt to have this nice user interface. And there's just a, like you can just launch from the command line. Like there's two commands. We have, there's MGBA and there's also MGBA dash Qt, right? So the just running MGBA just opens like a bare SDL window with like no, like the aspect ratio gets all fucked up and stuff. And there's no way, you can run the debug server, but there's no way to actually access this scripting thing. Like the only way that I'm aware of to run MGBA scripts is to like launch this GUI window from the toolbar and load the things by clicking, which is not ideal, certainly, but gotta do what you gotta do. If we get really deep into this, which I suspect we will. This we might end up making some contributions either to a fork of MGBA that I'm just using locally, or try and upstream some stuff. But for now, we'll deal with this. That is flickering a whole lot. It's flickering less on the stream, I suspect, than locally, because I have my stream set to 10 FPS, because really what's the point of rendering faster than 10 FPS if you're just drawing text? But it should be fine for now. It doesn't seem to be too stressful. At least I'm not having seizures. Let's press A again. We can watch things change. We go back to mode 0. Cool. Go back to mode 2. You can see a very quick, might not even show up, a quick flash to is field message box hidden. Let's try and do other things. Let's move left 3. Oh, not move left 3. Let's move right 3. Let's get our directions straight. Let's move down 4. Let's try and leave. Get yelled at. Yeah, we're being told is field message box hidden. Now that's interesting, because we are in is field message box hidden mode, right? We would expect our previous understanding of this mode was that we were just waiting for text to be done displaying. However, and that we'd be waiting for an A or B press right now. However, we're in this mode with the down arrow, which I think is like meant to indicate there is more text, right? So we have to press A to get more text. We haven't actually changed our native pointer status in the state machine. So there's something else that is waiting for the A press right now. Maybe it is just is field message box hidden. Maybe is field message box hidden handles like all of this like multi-line text stuff that we need to press A to get the next bit of. So I guess let's just press A and go bravely forth. Yeah, so now we're at the end of the text. We no longer have the little show more button. Now we're waiting for an A or B press. So let's maybe the thing to do is just like when the is field message box hidden thing appears, our client should just be like spamming A presses to get out of it, because that seems like the correct thing, right? It's not going to do any harm. I worry about like race conditions though, because like that state can like discharge itself on its own, right? We can, I suppose, go from is field message box hidden directly into like a yes or no prompt or something, right? So if our timing is wrong, which I think it often will be if we want to be running this in, like, I think any design of our eventual bot will want to consider running the emulator in like unlocked FPS mode to get through some of the admittedly tedious text scrolling parts of this game more quickly. So we'll have to be mindful of that, and like whether, so it'd be nice. I think what I'm trying to say is it would be nice if we had another way to tell if that show more text red arrow is on the screen. So maybe we'll do that. Let's check it out. Let us investigate, as they say. Okay. Either way, let's press A. Go back to mode 0. Move up. Let's just move up 6. Yeah, fine. If we move left 3, move up, press A. Yeah, we get the same. This will be a good place to test. Okay, so let's look into the details of is field message box hidden. I think that's going to be our next point of order. Okay, what do we do here? Let's kill. Where even are we? Jeez. Sometimes MGBA's GDB server sends us some very strange locations. Let's actually get back to somewhere we know. Okay. Let's go to script.c. Let's go to all right. Is field message box hidden? We gotta find that. Is field message box hidden. Cool. That's, well, we looked at this before, right? Well, there's probably a whole system that like manages this field message box mode. It's probably all in here actually. And it probably handles whether button presses are happening and stuff. Yeah, that's a thing. Maybe, or maybe there is, maybe this is all like present in the game dialogue files. Maybe there's, I see this string expand placeholders. Maybe there's like a escape or like some like special thing within the dialogue state machine, if that exists, that says, hey, draw a little arrow here. I could envision that easily, and that's, well, I would hope that, well, we're hoping we're not just going to end up with state machines on top of state machines, but I sort of feel that's what it is. What is that even called? What do we think our, well, we have use alternate down arrow, which makes me think that there is just a plain old down arrow. Search down. That is the only instance of down. Huh. This is trickier than searching for our Fugi, because the Fugi we could just search for that text. Right here, presumably there's some bitmap somewhere that describes, and we don't want to mess with that. We're gonna do it kind of some elbow grease. Oh. Let's see. When we have field message box, this is unused auto scroll. Go field auto scroll message. Well, probably the name of this thing has something to do with scrolling. Well, what if we go to field? Is there a field message box.h? Yeah, there is. We've been there. There's hidden, unused, normal, auto scroll. We're in normal mode. What are the implications of normal? This thing is static, right? Is there any... Where could it be? Field message box. Oh, there's a get me. There's a getter. We have some encapsulation happening here. That's some cool stuff happening within the source code of Pokemon Emerald. All right, let's see. We have a bunch of stuff happening here. This is some special case for handling the cable club for some reason. I guess. I guess the check here is mostly not equal hidden. We have, well, okay, so maybe what we do is we find the dialogue for that TV. What did the TV say again? Oh, we're gonna have to bring me MGBA. Continue here. Press A. TV said mom might like this program. So we're going to search for the string might like this program. And we're going to see what we get. Hopefully something good. RGA. Might like this program. Yeah. We were good to not search for mom might like this program because we got some shenanigans happening. We're going to Where are we going? Event scripts.s. Might like this. This is probably a super long file. I bet that 1058 is actually it. No, it's just 1058. So the script of this game is probably shorter than you'd think. Might like this program. Mom or dad might like this program. It's just 3 strings. I don't know if this dot string inserts a null terminated string. I'm assuming this $sign indicates the end of the it's like an end of message thing. Like, I mean, there must be some way to disambiguate the end of, or maybe it's just a new line. I guess there's a, I think this is a paragraph separator. That's interesting. We can find string expand placeholders. That seems like maybe what we want. RGA string expand placeholders. Yay. Okay. String util.c in gflib. Okay. String expand placeholders. What are the placeholders? We have placeholder begin, which who knows what that does. Bunch of control codes controlling font and layout, I think. An end of string. We have a scroll prompt and we have a clear prompt. Okay. That seems exciting. Char prompt scroll. And that we're just switching on C, and in those cases we just include C in whatever is expanded. So maybe this, what does this write out to? The first argument? Yeah. So gstring_var4 here, our global variable that contains whatever string we're printing, is going to contain some char prompt scrolls, potentially. Let's find out what char prompt scroll is. Waits for button press and scrolls dialog. Well, that seems exactly like what we want. It's 0xFA. Well, I don't know how, I mean, as I mentioned hours ago at this point, I think there's some post-processing shenanigans here that happen because like the game's text is not actually in, like, it uses some weird encoding that is not ASCII or Unicode or whatever. It's a custom thing. So like looking for this character literally like is not going to, like, there's probably something that inserts that, potentially based on new line characters, question mark, or maybe it's okay. Let's bring up mgba again. Let's continue. Oh yeah, so that's after, it's that paragraph break character is what does it, right? Because let's, yeah, that's it's we printed both. Okay, let's press A. If we just wait, it prints both of those lines, right? It prints the first line, it prints the new line, it prints the second line, and then it gets that paragraph break character and it prints this char char prompt scroll thing. So that's cool. So we know that whatever our post-processing step or in our build process replaces \p, which I assume that's a paragraph break. If we say man ASCII, Being told that C program escapes are noted, so I don't know. Well, I don't know. It's a mystery. Let's solve it though. Let's just search all the escape sequences. Wikipedia, save us. It's not a C escape sequence even. Maybe. Thinking about it, maybe these strings don't even have escape. Like these are just like strings like used in these assembler macros. Maybe these are not, it doesn't even have escape sequences. Maybe these are like maybe this like string actually has these two characters and it's then parsed by some macro somewhere that like does the escaping. So either way, we won't worry about it. We just know that a \p in here means char prompt scroll. I think, I don't know. We'll keep this in our brain. We're kind of recording it implicitly by actually recording video, so probably won't lose it. All right, so we know char prompt scroll controls the display of that character. So next we need to find out where that is handled. Let's just search again for all our char prompt scrolls. There's this source /easychat.c. That seems maybe promising. Prompts. Does that do what we want? Convert unused. Oh, well, this is an unused function. Well, that's fine. Yeah, well, I guess it's probably in gflibtext.c. So we have this text printer that itself has, okay, there's our other state machine. There we go. We have a text rendering state. Excellent. What initializes that? Where are we? Init down arrow counters, that sure likes it. That maybe looks like it, like I think our little down arrow kind of bounces a little bit. So it clearly has some state that's changing frame by frame. That looks like something promising. Where is our this text printer thing? Oh, yeah. This is quite a function. Text printer is struct text printer. Text.h struct text printer. Gonna substruct. Oh yeah, and there's our state related to our down arrow. That bounciness. We found it. It's here. We got a 10. Okay, yeah. There's a lot. Whole lot. Well, either way, the thing we probably care about is the state. And so what does that mean? We're looking for char prompt scroll. So when char prompt scroll is detected, it sets the state to render state scroll star, presumably, which is something. Let's find that. Render state scroll star. It's just in this enum, so it's probably 0, 1, 2, 3. Let's make a map of the text rendering states, maybe. This is scroll start, not scroll star. I was just not reading far enough. Well, let's dig in a little more. Because, well, I guess the thing we need to find next is the global address of our text printer state. And there's probably a text printer that is set up by the stuff in here, this add text printer for message. That looks promising. For message, man, this keyboard sounds awful. It's in menu.c. Menu.c. Add text printer for message. So we do a whole little thing. We make our callback is just a null pointer. Add text printer parameterized. There's all kinds of, we have a lot of layers of indirection here. This add finally makes this text printer template, calls add text printer. Where is the actual add text printer? Let's find that. We don't want that to be open group. Back in text.c in gflib. Okay, that makes sense. Add text printer. No, add text printer. Yeah. It gives it template. It's stemp text printer. Oh, I see. So this is per window. Yeah, that makes sense, right? Because you can have multiple dialog boxes on the screen, right? Like you could have, thinking about like how dialogue in Pokemon works, you have all kinds of pop-ups, right? You can have someone talking and a yes or no box pops up and potentially more layers. So we have like a bunch of text printers. Is it a stack of text printers maybe? I guess we'll see. Well, maybe this temp text printer is the last, I mean, it's the last one added. Which is potentially exciting. So this does some nonsense. Maybe if we just print s temp text printer dot state. Nope. Print s text printers. One of them is state 2, which is clear. One is state 0. Maybe we are in state clear, not state scroll start. State scroll. Well, either way, it's good to know. So let's. Well, this text printer is indexed by the window ID. I wonder how far we can get just by looking at the 0 index. Well, I guess there's probably a list, like, there's probably a way to get to query all of the window IDs somewhere. But that might be a whole other can of worms that we have to delve into, open up and feast heartily upon. Huh. think let's try that. Let's just grab this. That looks fine. That's going to be render state clear. What's the address of that? We'll see if that, so what we'll do, info, text, render, text printer state, I'll call it that. And that is, what is that? Is 1 byte. Yeah. Yep. And we'll say text, we'll call this text state dot text render states text printer state. Being very inconsistent with our naming scheme, but these things are sort of not super critical right now, because we're really only going to be using these maps once, and all this stuff on the client side in this fennel code is kind of transitory in the end. All we need to do is get the information out kind of by any means necessary, and then we'll do interesting things with it later. Okay, what are we doing here? 0 is handle char. 1 is, let's just actually grab all these. I'll just, cool. We have some script modes. If we go back, oh, we're not calling those script modes. These are text render states, excuse me. Now we can get our text state in addition to our current, what is that called? Statement, like current script state machine mode, and our current, like the current function pointer that's in our native pointer in the script state machine. We're also just looking at the 0th text state machine and grabbing its printer state, which should tell us whether or not that red down arrow is on the screen. Let us see. Going back to our emulator. Back over here. Run the thing. We're not, oh, we need to reload the script. That's why. That will do it. Reset. Load a script. This thing is flashing like hell. I don't know why. I'm kind of frustrated by it. We're being told that we're in text state clear. So then if we go here, run netcat, press A. We're in text state handle char, press A. Handle char seems like that's the default state, right? Yeah, this is just like we need to print a thing. Yeah, it changes to clear when that, let's change our text speed to slow again. And then we can maybe see a little more clearly how things are changing. So if we press A, We're in handle char mode, right? And as soon as that appears, we're in clear mode, right? So now we know we need to press A if either we're in both text state, if we're in text state clear and we're in is field message box hidden status, we need to press A. Otherwise, if we're in wait for A or B press status, we need to press A. And that should get us out of most like kind of trivial dialogue situations. We're not yet handling yes or no prompts, but this should be enough to handle like just like talking to NPCs, like blasting through cutscene dialogue, maybe things like this. So I think it's been 2.5 hours, and this is my first time doing this, so not super comfy just yet, and it's been maybe a little bit scuffed, but I hope okay and instructional overall. So I think I'm gonna call it there. I'll probably be back next week with continuing on this journey, and we might get started a little bit on the actual client side rather than just using Netcat and trying to like consume this state that we've just managed to generate and use it to send back the A presses automatically based on that kind of like those rules we just described. And maybe start handling some more complex scenarios. I think my my long-term goal for this project is I want to have a simple, understandable bot that can navigate the areas of the game, like probably have some like high-level description of like, okay, what is the path of the story, but then can navigate the areas and do battles automatically, choose moves in a somewhat intelligent manner, etc., etc. To get to the point where we can have like maybe like one or two like relatively small amount of code on the client side, and we can beat the whole game with that, right? Like obviously we can build like we could build some gigantic bot, right? Like some huge amount of code that like is some rat's nest of like all kinds of special cases that we could use to beat the game pretty easily. But I think a cool artifact to have at the end of this would be something small and understandable that is able to like navigate the whole shebang, if you will. Also, a stretch goal, I guess, would be I would love to build something smart enough that it can get all of the Battle Frontier symbol thingies, because that's something I've always wanted to do, but never have, mostly because it's tedious, because you have to like grind through fucking 50 battles every facility. So if we have a bot that can battle for us automatically, that would be a cool way to solve that problem. Well then, so yeah, this is LLLL Colonq signing out. I hope to see you all soon. Take care. Bye now. I guess the thing to do in situations like this is to raid someone. But let's see. Do we actually have viewers? That is the question. Well, we only have 2. I think probably the polite thing to do is not to raid. So we'll save it for another time. Alrighty, see you later. Bye. Bye. Penis.